Matthew. I think. Did you guys get the message?
Yep, we got the
Okay,
message. So, yep,
excellent. So real quick, Matt, I'm just going to say,
yep,
hey, everyone, this is our special project grant cohort meeting. February, it is February 2025. And we are going to, well, Matt Gardner is going to lead us through a safety presentation and Q&A. So turning it over to Matt.
thank you, Jill. Yep, so we're gonna do the Explorer Pioneer Ranger safety briefing. Let me share my screen real quick, but before I do that, I will say, please ask questions. I may not be able to see if you raise your hand or something, if I'm in full screen for this presentation. So just add a break. If you have a question, just interrupt me and ask that question. Okay. So there we go. Hopefully everyone can see that, right? Okay, excellent. Thank you, Jill. Um, so again, in this briefing, we're going to go over the safety components for the World Championship. For those teams who are attending a regional, you can contact your regional coordinator for information. You may or may not need to do all the things involved in the safety inspection, turning in the documentation prior to the competition, um, or not. So contact your regional coordinator about that. But this is really going to go everything we require for the World Championship, and regional should have many, if not all of these components. So really there are three things we're going to be going over and talking about today. The initial safety inspection, which is also uh, similar to the video qualification, the safety portion of that. So they're going to be similar items. What inspectors are going to be looking for similar things in those. So if you're doing a video qualification, that's kind of your first safety layer instead of a regional, going to a regional and getting safety checked there. Then we're going to talk about the on-site safety inspection before the competition, right before the competition. And then we're going to go over some examples and photographs of what is and what is not allowed, with examples and photographs. Okay, so we're going to jump into it. And as I said, I'm going to start talking about the initial safety inspection, the company safety review. Um, and essentially, when you turn in your documents, our safety inspectors, our safety group is going to go through all that documentation, including SIDS, company safety review, your float document, your non-ROV device information document. But I will say this does not include your technical document. Our initial safety inspectors are looking at that. So never say like, oh, it's on page 17 of my tech report. Because they may not have access to that. So if we ask you to turn in a SID, turn in an actual SID. Don't say, oh, you can find it on page 17 of this document. Okay, so let's look at what the safety inspectors will be looking for in the initial safety inspection. And this also goes for the video qualification safety component. And the first one, Anderson power poles as a main point of connection and a properly sized fuse, which you're going to figure out from your full load amps value. And for if you're using a 12 volt system, so that's Ranger class or Pioneer class using 12 volts, that's going to be your red black Anderson power poles and either an ATO or mini blade fuse. And for Explorer and Pioneer using a 48 volt system, you must use an Anderson SBS 50 connector, and you must use a Littell fuse of the type specified in the manual. There are links in there, and you have to use those exact components. And I will say that's the biggest mistake a lot of first time teams make, those just coming into competition. They don't have that proper Littell fuse. They don't have that proper SBS 50 connection. So make sure you get those. There are links to those in the manual. For full load amp FLA values, um, this is another common mistake that teams do where, they do their calculations or their figure out their full load amps and it says, hey, we should be using a 20 amp fuse, but then they're like, oh, we're just going to throw in a 25 amp because that's the maximum limit, or we're going to throw in a 30 amp because that's our maximum. If your value says you want to be using a 20 amp fuse, use a 20 amp fuse in your system. The inside of the control box, gonna look at your control box just to make sure there's no exposed wiring. Everything's laid out neatly. If you're using AC for something, that is separated and identified as AC as opposed to the DC components. And of course, you are allowed to use AC for surface components. Just make sure it is identified. For strain relief, that's both going into and out of your ROV, but also into and out of your surface controls. So look for wire abrasion, make sure those wires aren't rubbing against anything, um, that might cut into them. And strain, essentially, if that wire gets pulled on, we don't want that strain to be on a solder connection or other connection. We want that strain relief to catch that, so you're kind of pulling on either the entire control box, the table, or something that's not going to pull on a connection. For fluid power, if you're using fluid power, hydraulics or pneumatics, you need to have a fluid power SID turned in. You have to have passed the fluid power quiz. So we always get one or two teams asking really late, oh, I forgot to take the fluid power quiz. So if you're using fluid power, make sure you take and pass that fluid power quiz. Show that you have all the components you need for that, for a compressor, a pressure release valve, an on-off valve, and a regulator in your system. And then also make sure that all your components meet the pressure regulations. For pneumatic, you should show for pneumatic hoses, show the pressure rating on them. They should be stamped for that. And generally, for pneumatics, you're limited to 40 PSI. Your components need to be 2.5 times that, so rated to at least 100 PSI. Okay. So all propellers are shrouded and guarded to IP20 standards. And that guard must cover all things. Both sides of the propeller. And IP20 means nothing of 12.5 milliliters, 1.25 centimeters can touch the propeller. So that's about ½ inch or so. And that's what I'll talk about this later, but that's what our safety inspectors are gonna look for. And then lastly, the ROV has no sharp edges or elements that could cause damage. Um, we'll talk about the missions that might require a sharp this year, or something somewhat sharp, and what to do if you do require something that's a little bit sharp. And so your company safety review, and your qualification video, if that's where you're going as well, should include an explanation of how the system meets that, but also include photographs. As I say, a photo is worth 1,000 words. And I know when I grade these, if I see a photograph of what I want to see, and there's that SBS 50 Anderson power pole connector, there's a fuse right next to it. I know you're good. I don't have to read that explanation, but do include that explanation anyway. So yeah, upon reading this document, seeing the photo, it should be clear to the safety inspector on how your ROV meets all the required safety items. And as I said, the same goes if you are qualifying for the World Championship by video qualification, show those components for the required time. We don't want to see a shaky camera. We just want to look at it, be able to see that you're meeting all these safety requirements. Okay, so here are some examples of a company safety reviews, both for a 48-volt system. So if you're Explorer or Pioneer using 48 volts, there are two to look at here. And there are also some for 12-volt systems, Ranger class and Pioneer class using 12-volt systems. And both of these have a company that they included everything in them. And then there's also a company that this year didn't use fluid power and didn't have a float. So it kind of shows both ways of, and essentially, if you're not using fluid power, just say somewhere in your company safety review, hey, we're not using fluid power. It's perfectly okay. Same thing for the float. If you're not using a float, just say, hey, we're not using a float. And it's easy for the judge to know, oh, they're not using a float. We'll disregard that section. Okay. Now I will say these are from 2 years ago, and this year we did institute the full load amps instead of fuse calculations. So just know that these will probably have, well, they do have fuse calculations in them, and that's the one thing that has changed for this year. So companies advancing to the World Championship, you must submit all this documentation on or before May 21st. And as I was saying earlier, it should be, you're submitting your technical documentation as well, but all the separate documents should be submitted separately. Um, the manual has a list of everything you need to submit. Last page of the manual has everything you'll need to submit, and there's more information on what you should submit. And as I said, the safety inspectors are going to look at your documentation and give you an evaluation. And this is really important because essentially this is a chance for you to get a heads up on a potential issue 3 or 4 weeks prior to going to the World Championships, before going to the World Championship. So it really gives you an opportunity to fix that when you're still in your lab, still in your workspace, and you still have all your stuff around you. So, as I said, we want to find those problems early so we can fix them. So get that issue to you so you can fix it before you get on site and have to do your on-site safety inspection. Okay? Any questions so far? Okay, so let's talk a little bit about floats, your non-ROV device independent sensors. So only the vertical profiling float this year is considered a non-ROV device. But for an independent sensor, you could have your pH sensor for determining the pH of the water sample, and your 360 photosphere could be considered independent sensors. There are rules for that in the manual that you can look at. So essentially for your non-ROV device power, this must be from onboard batteries, and you're limited to 12 volts and 5 amps. So as I said, your battery pack must have a 5 amp or less fuse at the point of connection. We're limiting what kind of batteries you can use this year, AAA, AA, CD, 9 volt, or nickel metal hydride or AGM batteries. The manual has some amperage limits for each of these battery packs. I'm not going to go into those there. There's a great table in the manual. But if you are using a certain type of battery, you are limited to that number of amps. And then um the amperage limits for each one. Onboard batteries, they should be mounted so they're not loose, or they're in the container, so just image of that. The battery container must be designed so that it will open or release if pressure inside becomes greater than the external pressure. So if pressure starts building up, you either need an end cap to pop off or a rubber stopper in a hole that's at least 2.5 centimeters that will pop out. And then, of course, a SID is also required for the float. So if you're doing a float, you also, not only do you need your main ROV SID, you need a SID for your float as well. Okay. Sorry, let me there we are. Okay. So for documentation of your non-ROV device, you must provide a written explanation of your device, and it should include a lot of just information on how you're powered, about all the devices. So what we're requiring is a photo or diagram CAD model of your float, the type of battery used, and a photo of the battery pack and the fuse. So you need a photo of that in there. Table of measurements showing the full load amps, so just like you do for your ROV, you're showing your full load amps. Description of how the battery pack was designed to safely fulfill the load, full load current needs and voltage requirements. So that would essentially be, just somewhere in there saying we use 2 power packs, both with 8 D cell batteries in them. So that's 12 volts. And each of those power packs is D batteries are 1.2 amps each. So that gives us 2.5 amps total. Our full load amps is 2.1 amps. That's what we measure as. So that covers us. We're good for 2.5 amps, and we're pulling using 2.1. So that would be a description of how your battery pack was designed to safely fulfill the full load current needs. Just a quick description of your buoyancy engine, what you're doing to go up and down. Are you pulling a syringe up and down? Are you inflating a little bag to go up and down? Just how are you doing that? And then just a quick description of how your float communicates to the shoreside station. Is it Bluetooth? Is it something else? We don't need a detailed description full of diagrams. We just kind of want to know the basics of, hey, how are you doing this? And then, of course, as I said, you need a float SID. Okay. So the initial safety inspection penalty points, these are just some common things that teams do to that might happen, so they lose some points. So submit it on time. I always love getting things a couple days early. The date's May 21st, but you can always turn in something a little early. Use a proper naming format. Every year we get something turned in that just says tech doc or something, and that's great. You're turning in one tech doc, but as receiving these documents for the World Championship, I'm counting on probably 80 plus documents. So just name it so we know whose it is, and it's easy to put in the right folder if it gets lost. The SID, you need to show a fuse and use a proper symbol. Make sure you get your full load amps values on there. If they're not on there, you're going to lose some points. If you're using fluid power, make sure you turn in that fluid power diagram. If you don't, you're going to lose points for that. And if you're using a float, make sure you turn in all the documentation for that, the SID and the float document. And again, as I said earlier, if your team's not doing test three mate floats, if you're not building a float, that's perfectly okay. Just let us know that in your documentation, in your company safety review. Okay, so we're going to move on and talk a little bit about JSEA's, Job Safety and Environmental Analysis. And the JSEA, it's a checklist of the steps required to do a task, identifying potential hazards for each task, and what measures are taken to eliminate or remove those tasks. And so this year, unlike last year, the JSEA is required from every team. So this is a required document for teams advancing to the World Championship. For your regionals, if you're going to a regional, check with your regional coordinator to see if it's required or not. And another note about this is the JSCA should focus on the product demonstrations, and it should be specific for operating the ROV in water, your deck side setup, operations, breakdown of the system. You know, detailing your lab safety and how you dealt with tool safeties when you're building. That's fantastic, but it's not part of the JSCA. So it really focused on operations and poolside operations. And then again, for each specific step of ROV setup, operations breakdown, identify potential hazards, what you're doing to mitigate that or lessen that hazard, and who's responsible for taking care of that on the pool deck. That should all be listed in your JSEA. James, do you have anything else you want to add on JSEAs?
No, sir. I think you captured.
Perfect. Thank you. And then a couple links here. You know, if you want to see the Oceaneering International Employee Handbook, chapter, sorry, I can't see it, it's covered up, but you can see the link there and look at JSCAs. And then we have two very good JSCAs from last year. I think James scored excellent on one of these, or great was the other comment on these. So you can look to see what these two teams did. We have Alexandria University Aquaphoton and Seacow Robotics did an excellent job on their JSEAs. So you can look, see what they did, and not exactly copy it, but do a very close copy of what they did. Okay, any questions on JSEAs?
Hey,
Okay, yeah.
real quick, and yes, follow it as a model. Don't copy it.
Right.
Hey,
You're
just
not copying exactly, but yeah, look at what they did, model yours after that. And as I say, I don't want to say it should be an easy 10 points, but you know, this is one of those where pretty easy to do it right, and you get your 10 points.
yeah, and Matt, I have a question, and
Yes.
apologies if you covered this, but this is a great PowerPoint with a number of external links, and you plan to share the PowerPoint along with the recording. We'll post that to the website, right?
Yes, and I think this I can't remember what I've posted in the last 2 days, but it might already be up there. This video will be going up there as well. So yes, look in the website in either your competition class page, in the World Championship page. All these are listed. And of course, if you're a regional coordinator or a volunteer later on, they're in your areas as well. But yes, all of this will be online.
Thank you.
Okay. Is there something? Okay.
Yes, Olaf has a question.
Yes.
Yeah, just really quickly, earlier in the presentation, you mentioned a limit to 40 PSI in the pneumatics and the hydraulics. Does this also apply to the buoyancy engines inside of the float?
Yes. So the 40 PSI is for pneumatics. I believe hydraulics is 150 PSI. I don't have that number in front of me. But yes, that is in the float as well.
Thank you.
Yep. Okay, so that went over kind of all the stuff that you are turning in early. Now we're going to be going to the on-site safety inspection. And so 2 days, and again, this is going to be about the World Championship. Your regional may be a little different, but essentially 2 days, in the 2 days before the World Championship competition starts, you're going to undergo an on-site safety inspection. And as I said, for teams going to regionals, it's usually competition day, might be the day before, depending on the regional. But essentially, you're going to bring your ROV and all your other systems to a safety inspector. They're going to run you through a safety inspection. Now, if they find an issue, they will let you know what that issue is, and you can take your ROV away and fix that issue. When the fix is done, you bring it back to them. Oftentimes, they'll schedule a time for you to come back, and they're going to look it over again. And of course, if there's another issue, or if that first issue didn't get started or didn't get fixed, they will let you know what the problem is. And before that last one, oh, hang on, I see Scott Fraser there. Before that last safety inspection, your judges, your safety inspectors, they will go with you point by point to try and figure out, hey, here's how you want to solve this issue. So it's not just like, hey, here's the issue, go solve it. If it's that last time, if it's after that second one, and even after the first one, they're really going to work with you to make sure you get that solved. Because if you fail that third inspection, that's it. You are disqualified from the in-water portions. But again, our inspectors will work with you to the best of their ability to make sure that does not happen. Okay, so the competition staff is going to conduct a safety inspection using the safety inspection rubric. And that is posted. They just went up this morning. They're out there. So if you want to know exactly what you're going to be, what those safety inspectors are going to look on, you know, download that safety inspection sheet and you can go through it exactly. Okay. And again, I just talked about this, but you know, the safety inspectors will let you know the issue, give you a chance to correct it, and really work with you to make sure you get it corrected. Okay. If during the third time, you know, as I said, if you fail that third one, you can't compete in the water, but you can still compete and participate in the engineering and communication portions of Tech Doc, the engineering presentation, and marketing display. And then when you do pass your safety inspection, you will get your blue pass card. It'll have your team name, team number on it, and what you are allowed to do, whether you're approved for fluid power, lasers, things like that. And that is your key. That blue pass card is your key to get in the water. You can't get in the water until you do that. But if you want to, get in a practice pool, you know, you need your blue pass card. Before you go to the station, well, as you go to the station, you need that blue pass card to get into the water. Okay. Okay. So as I said, the score sheets and rubrics are all posted. So again, if you want to know exactly what you're looking for, go to your class page. You can also go to the scoring page. They're not up there yet. They will be shortly. Or you can find them on the World Championship page under the scoring section. So everything is out there for you to look at. And speaking of which, can't really read them here, but this is kind of what they look like. We have a new header for them. But again, you can see the list of everything they're going to check for. And then on the back, that's where they list any issues you have. So this is for Ranger Pioneer. This is Explorer. And again, it's all out there for you to see exactly what you're getting scored and evaluated on. Okay, so any questions about the on-site safety inspection at the World Championship? Again, I think a lot of regionals work the same way. It's just that maybe the morning of your competition. Okay, so we're going to look at some examples and photos of items that will and will not pass a safety inspection. So, number one, all items attached to the ROV are secure and will not fall off. So this camera is loose, just kind of hanging, wouldn't pass safety inspection. This one is on here, and generally, at least when I do safety inspections, maybe not for the big, heavy ROVs, but just, give them a gentle shake and see if there's anything loose there. But also note that large monitors, if you have a big display monitor or a bunch of monitors up there, you want to secure those as well. As you wheel those in and have them on your desk, you don't want them falling over. That is a loose monitor, could be considered a loose item as well. So make sure you deal with that. No sharp edges or elements of the ROV design that could cause injury to personnel or damage the pool surface. I don't know where we got this picture, but they have these nice old spikes out the front. I don't know what purpose they serve, but this is not something you want to do. They may look cool, but they would fail our safety inspection because they could damage a diver, a mission prop, the side of the pool. Again, talking about monitors with glass fronts could create sharp edges. So don't use anything sharp like this. You don't want to use fishing hooks or something like that. Now you could use a grappling hook or something. Just make sure there's not a sharp edge on the end of those points. So, a grappling style hook would be fine as long as it doesn't have any sharp edges. But again, glass monitor, we had a couple years ago, a team showed up with old monitors that had glass covers on them. And again, if that breaks, that could create a sharp. And of course, no glass anything should be going into the pool just in case it breaks. Okay, now hazardous items are identified and protection provided. So let's say you need something sharp to complete a mission. This year, you are going to, for Explorer, Pioneer, and Ranger class, you are going to have to puncture through some plastic wrap, some Glad wrap, Saran wrap to get to that water inside the 2-gallon bucket. Don't think you're going to need something really sharp. It is just thin little piece of plastic. But if you decide, hey, you know what, we need something somewhat sharp, here's what you want to do. So this was a couple years ago. This team, the sharps are colored red, and then they had this black and yellow safety tape marking around it. And so really what I'd say is if a sharp is required to complete a mission, be able to explain to the judge, safety inspector, why it is needed, why you're using this, and then just show the judges, safety inspectors how you called it out to make it safe. Okay, all propellers must be shrouded even if they are enclosed inside the frame of the ROV. So here are some great images of shrouds. These are from the Eastern Edge Robotics vehicle. And so again, these are going to be shrouded to IP20 standards. That means no hole larger than 12.5 millimeters, 1.25 centimeters, which is about half an inch. So safety inspectors, they're usually going to have a 1/2-inch wooden dowel, and they're going to kind of poke it around, try and get it into your shroud. And if that 1/2-inch wooden dowel can touch a propeller, you're not going to pass safety inspection. So these shrouds were 3D printed, but you can have other ways to do it. You can build your own from something else. Again, just be sure that that 1/2-inch dowel can't touch a propeller from any angle. Okay, so let's talk about a single attachment point to the power source. For a 12-volt vehicle, you're going to be using the red-black Anderson power poles. They do need to be clipped together. You don't want them loose here. And again, you're going to want to fuse within 30 centimeters of this. One other thing to note is if you are doing these on your own, you should really have an Anderson crimper, power pole crimper. Your normal standard crimper, which just kind of squishes things together, aren't sufficient for this. You need a proper crimper to get that roll. So as I said, if you're making these on your own, make sure you have your Anderson power pole crimper to get these to fit together. Now, for the Explorer and Pioneer using 48 volts, you are going to be using your SBS 50 connector here. And again, as I said earlier, this is probably the biggest mistake that most first-time teams make is they do not use the SBS 50 connector, or they do not have the proper Littell fuse here. So this is a must. Want to look for that light blue one. There are a couple knockoffs, but those knockoffs don't always work. They don't always fit together. So there are links in the manual for where to get these, but get your proper SBS 50 and get your proper Littell fuse. Now they come in a couple colors. I believe this is the 30 amp one. The other ones are another color, but make sure you have these exact components for your ROV. If you don't, you're not going to pass safety. Okay, so these would not be allowed. This is a single, these banana plugs, we don't use banana plugs anymore, but this has some other problems is there are 3 linked together here and only one of them goes through the fuse. So this would not pass safety inspection because it's not a single point of connection. There are 3 points of connection here, and it also doesn't have a fuse within 30 centimeters. It's only on one of these lines. Okay. So this is really what we want to see here. As an example, the top one is an Explorer vehicle from Long Beach City College. So other ones from X Academy. And as I said, when I'm looking at safety, this is what I want to see. I want to see the Anderson SBS 50, a short bit of wire, and the fuse. Now, what you do downstream of that, that's on you. But we don't want to see anything in between here. They made a nice little handle, but that's not any electrical components. But I know, teams have put a e-stop in here or some other like on-off switch. That's fine, but just put it after your fuse. We want to see your connection to power, a short bit of wire, your fuse, and then what you want to do is beyond that. And the same thing for this 12-volt system, your red, black Anderson power poles, wires, your fuse, and then whatever you want to do downstream of that is up to you. Okay, let's talk about full load amps. So
Hey, Matt,
this
real
year,
quick, did
yep.
James, did you have a comment?
No, I'm good. Thank you.
Okay, sorry, I thought you.
Okay, yep, yeah, sorry, like I said, I can't always see it. So excuse me, full load amps, you need to have this somewhere on your company safety review. It should also be on your SID, and then the fuse chosen should match your full load amps value. So with your ROV in the water, run all your thrusters full forward at the same time. So all your thrusters running, measure your amperage. That is your full load amps value. Should not exceed 30 amps for a 48-volt system, 25 amps for a 12-volt system. And then that's what you report. So, this down here is what you would have something similar like this on your SID and in your company safety review. It says when the condition was full down thrust, full forward thrust, all the things moving, our measured amps our amperage we measured was 25.1 amps. Then you look in the manual and select a fuse size based on that, which in this case would be a 25 amp fuse. Okay, talking a little bit about SIDs. Fuse symbols for your SIDs. We are very specific on using an official fuse symbol in your SID. So here are the 4 symbols. They need to be either the ANSI, NEMA, or IEC symbols. And you can see them here. They're also printed in the manual. You can also just go on Google or another search engine and type in fuse symbol. You can get these proper fuse symbols, but use one of these symbols. If you use something else, I remember when I first started, when I was doing this S1, I'd on the drawing program, I'd get an S, cut off the ends and stick it in there. That's not good enough. We want to see this proper fuse symbol. So here are some examples of SIDs. And really what we're looking for is this higher level SID. Don't want to see pins going into an Arduino. That may be great for your knowledge, doesn't belong on a SID. I know there's a program out there that does, what pins are going in. That's not what we want to see. We're really looking for this higher end. And on this one, you can see they just have their 12-volt DC power supply as a box. So is their AC power supply. Few symbols in here, that's important to have. And really what this is, so judge, safety inspector can look at this and just get a quick look at what your vehicle does. So boxes, and when I look at this one, you can see 12-volt DC supply, fuse, power going down to the converter, going out to 8 thrusters, 5 servos, 4 cameras. Cameras are getting power from this 12-volt. This is just, let's see, brownish is camera signal. This is PWM signal. So again, that's what I'm looking for. I don't really care what component this is. Just, hey, it's a converter. I know what they're doing there. Okay, and again, they have their full load amps on here. And I will say, this is something I added because this is new for this year. So if you actually go back and look at their actual one, they'll have what we had last year. Okay, so here's an example of a 48 volt one. Again, this is from Long Beach City College. And again, I can see they have their SBS 50 connector here, their fuse. And again, they have a bunch of other fuses, which is fine. Just want to see the ones here. And then going down, powering things, they got converters, 48 to 5 volt, 48 to 12 volts. I see they're using 5 motors, bunch of cameras. I can tell the cameras are powered from Mate Supply. When I see USB camera, first thing I look at is where are they getting that power from? Because it has to come from ROV power, not through down from the service, but they do that by powering their USB extension. So again, a good high level overview of their system here in their SID. And of course, they've identified what's on the surface and what's underwater. So any questions about SIDs? Okay. So we're going to keep moving on and look at some of the other things we want to see or don't want to see in here. And so the next one is no exposed copper or bare wire, no exposed motors. So I don't think anyone uses this kind of motor anymore, but no little electric motors that aren't waterproofed. But the bare wire also goes for in your control box. As we're looking in there, if you've stripped wires, make sure that you didn't strip so much that that copper's sticking out from your connection, because then it could touch something else and you could get a short in your system. And as I said, of course, your motors need to be waterproofed. I think most professional motors people are using now are waterproofed. No using jumpers in your final system. These are exposed wires. If this was in your system and one of these ends comes loose unplugged and that's bouncing around your system, that's going to cause all sorts of power. So I think as we say, these kind of things are great for prototyping, but in your system, make sure all your wires are secure and can't come loose. Strain relief. So proper strain relief, both at the ROV side and the surface side. This just shows ROV side, but here on the right is a good strain relief for the tether. If that tether gets pulled on, it pulls here, which is directly into the frame. It's not pulling on any connections where they go into a component. This one, on the other hand, no strain relief over here. So if this was pulled on, it's either pulling on the solder connections, which are somewhere in this tangle, or it could just be pulling directly where those wires go into the motor. So, no strain relief here, good strain relief here. And not always the case, but I do know James has asked teams to pick up their vehicle by the tether to see if that strain relief is good enough. So, you want to be careful doing that, but that is one of the tests that you may be asked to do. Okay, so this again, an old picture, but multiple fails in this photograph below. Hang on, where are we? There we are. Okay. These are some of those old monitors. I think they have glass covers, so that would be number one. There is a just total wiring mess here, a rat's nest, exposed copper. There are alligator clips here, which are exposed copper. Alligator clips are also no strain relief on any of those. If they get pulled on, it's right on a connection. This just spaghetti mess of wires. They're using AC here, but it's not clearly marked. I can tell this is AC, but where does it go from there? So, this is just not great. Multiple fails in this one. And we do have a Mate Tech bulletin on expected work practices that goes over wire discipline, connections, and more. So the link is in here in a slide or two, but you can look at that and get a much better idea of some positive examples of what we want to see. Such as this. This isn't an ROV, but this is very good wire discipline. As you just look at this, all the wires are laid out neatly, come together, zip tied together. These few then join the big mass. So, this is not an ROV, but this is something that we want to see in your control box. All the wires laid out neatly, everything organized. So just dangerous bad wiring. When you're building your ROV, just think about the potential safety, danger issues. Ask yourself whether if someone were not told about a wiring issue, would they be safe? And years ago, example I give is we had a team who they had some AC power strips and some AC power cords that they were using for DC purposes. So they plugged all their motors into a power strip and it was all using DC. The problem with that was that it looks like it's an AC component. And next year, if that went on a shelf and someone pulled it off the shelf a year or two later, they could look at that and go, hey, this plugs into a wall socket. Even though the team knew it was only DC, someone else in the future may not know that. So just, think safety when you're doing this. And there's a link on the bottom here for those mate expected work practices, which goes over lots of good rules for building your control system and your electrical in your control box. Okay, so we're going to move on to fluid power. Again, if you're using fluid power, make sure, number one, you have a fluid power SID, turn it in, and make sure to pass the fluid power quiz. And this also goes for if you're only using fluid power on your float that is using fluid power. So make sure you are passing the fluid power quiz and have a SID for that. Again, provide the specifications for all your components. So in your company safety review, just outline, hey, here's the tubing we used. It's rated for 150 PSI, which is over the 100 PSI limit. So we're good there. That should be printed on there. All the little components you're using, just make sure they are rated for the pressure you are putting through them. And again, that's for air, it's 40 PSI max, 150 PSI for hydraulics. And any component I believe should be 2.5 times that. There are some compressed air guidelines. So if you are using a compressor or at the World Championship, if you're hooking up to the mate supplied compressor, just some guidelines for what you should have in your system. A pressure relief, an on-off valve, and a regulator in your system. And also the components you'll need to connect up to our power.
Matt, I have a question
Yes.
about you said at one point that, or someone asked about the float is using hydraulics.
Yes.
If you have a syringe and the syringe is pulling in water and pushing out water, is that hydraulics? I mean, do you have to show that the syringe is capable of?
That is hydraulics, but it's not under pressure. So if you have a electrical motor that's pulling a syringe in and out, I don't think you would have to pass the fluid power quiz because you're never getting above ambient pressure there.
Okay,
Great.
thanks.
Yep.
And I'd like to ask another question about hydraulics too. Kind of sneak this in because I missed it when you talked about it. You have something called an independent sensor.
Yes.
Can the water sampler be an independent sensor? If it's totally if it's not, being powered by the ROV, can you just lower it down or even if it is connected to the ROV, if it's using a hand pump or, a syringe system, is that considered an independent sensor?
Independent sensors more for like an electronic sensor kind of thing. So no independent sensor should be using hydraulics pneumatics. That would be a different device. But what I will say on that is if it's hand powered only, if you're using a hand pump or a foot pump or a manual pump, you're pulling a syringe on the surface, which opens a syringe or closes a syringe on the bottom. You don't need to pass the fluid power quiz for that, but it should be somewhere on a SID. If you're using simple hydraulics like that.
Okay, thank you.
Yep. Okay, moving on to lasers. And I will say this is straight out of the manual, so you can look in the manual a little bit more. But if you are using a laser this year, your SID, you need a SID, or it needs to be on your SID, and it should show the power source for that. You need an on-off switch on your surface. You can turn it on and off. The laser does need to be powered through the mate surface supply. No batteries on board for that. As you see, if there are batteries used for it, that's not allowed, so you need to change that out. The classier laser, if you're using a laser, wherever you buy it, it should have all this information in the specifications for that. Bring those laser specifications to your safety inspection. So if the safety inspectors want to look at it, you do need to turn in any lasers and laser safety glasses, which you need. You need to turn in those specifications to the competition technical manager. That's me. At least 2 weeks prior to the event, just send in your specifications and the link to where you're buying them. I'll look it over, give you a thumbs up or tell you if there's an issue. And then I'll also let your regional coordinator know so they know to expect your team to have a laser. You need a beam stop within 30 centimeters, and this shouldn't just be something that you take and put off by hand. It should be something that either floats up out of the way or moves out of the way when it is in the water. And then, as I said, all members need laser safety glasses that are corresponding to the color of laser that you have. Okay, and that is it. So in conclusion, we just want all teams to think about safety. So our goal, we aren't trying to use safety to fail teams to get them to fail so they're not competing. And as I was saying earlier, if you fail your first safety inspection or second safety inspection, our safety inspectors are going to work with you to get that issue solved so you can pass your last one and get into the water. And I'll say we work with industry to align our safety specifications to industry standards because we want our students, students who are competing in the MATE competition, familiar with those industry standards because our hope, hopefully many of those students are going to be working out in industry one day, may still be a few years off for many of you. But we want you to be familiar with industry standards so they are second nature to you when you are out in the workforce. And as for safety at the competition, if you have a question, ask. In this case, it is better to ask permission than to show up with something that is unsafe and ask for forgiveness because you're not going to pass your safety inspection if something's unsafe, and then you have only an hour or two, maybe a day to remove that system and get it safe. So if you have a question is, hey, we're not sure if this meets safety standards, ask. We have our competition forum board where you can ask that. I will either answer it, or if it's a little more complex, I will reach out to our safety board, which is James and Scott, and occasionally a few others, and we'll chat about it, discuss it, and let you know whether it's safe. So really our goal is to, not have you showing up with something unsafe because then it's stress on you. You got to remove it quickly. And we just want everyone to have a fun, safe time. So think safety, good luck, and we hope to see everyone having a fun, safe time at the competition. Any questions?
Hey, thanks, Matt. I was
Yep.
just gonna say, great job. And as Matt said, our goal is not to fail you. As a matter of fact, as Scott Frazier put in the chat, we have never had a team fail the third inspection. So just keep that in mind. And Scott also put some other resources in, links to resources in the chat. So take a look at those and yeah, any questions, and I'll also, in addition to questions, I'll ask Scott or James to offer any notes or comments that they might have.
I'll jump in here. One thing that we saw, and it was actually surprised at the number of them that we saw were on the floaters, the water column profiler, is the lack of pressure relief on there. And there were a number of teams that were running out to Home Depot, getting a Unibit and a water, a rubber cork, drilling a hole into their floater and putting a cork in there because they didn't have that 25 millimeter pressure relief. And James might remember some of their excuses, but it was surprising the number of teams that didn't show up. Now, if you show up with a cylinder and the top cap or the bottom cap, whatever, is just held in by O-rings, that works in place of your 25 millimeter hole. And I don't know how so many teams, not so many, but a number of teams miss that requirement. Put that 25 millimeter hole in it, put a rubber plug in it, and you're good.
And I will say that's one of the reasons the this year for your float design document, there's a lot more we're asking you this year, including show us the end that pops off or that hole. And again, so we can catch it 3-4 weeks early and let you know that you need to fix it again before you come to the competition and have to overnight apart or run out to Home Depot.
Home Depot and Lowe's likes it when mate rolls into town. A lot of teams run into Home Depot and Lowe's to get parts to fix that they didn't
Yes.
get, so they can do this. They all end up passing the safety inspection. We work to get you to do there, but there's some frantic times when oh my gosh, we're going to be on the pool in an hour. Well, that's not going to happen.
Another area of concern is the overall workmanship of the design, your wiring. Yeah, you've seen some reference pictures in there. Anything you open up, you can open up your PC at home and see how everything is neatly laid out. That's what we're getting to, because it prevents you from damaging your RV. So it's yes, just keeps your equipment working. And if you do have an issue, it's easier to find when you can follow your layout of your wiring versus spaghetti wiring. It's all dumped into a control box. So as you are putting everything together, you're putting the final touches on it. Just keep that in mind before you show up to the world. Just it's something that we're starting to look at more and more.
Well, excellent. Thank you, everyone. If there's no more questions, I'm going to stop my share.
Yeah, thanks, Matt. Great job. And y'all, it's a small group, but again, this is going to be posted and shared with a larger community. And so just to reiterate what Matt said, and we're going to keep stressing this, right? Reach out and ask a question. It is better to ask for permission now than forgiveness, because you're going to be running out to, you're not going to get forgiveness in a sense. You're going to be running out to Home Depot and Lowe's to fix your issue when you're on site. So reach out if you have any questions. It's best to do that before you come on site. And then when Matt and others go through your initial safety inspection sheet, Matt will do that, and he will enroll others to do that, to give you good feedback in advance. So anything that's on that Matt reports back to you, that's a safety concern and you should address, be sure that you do that. And that will just make you showing up really well prepared at the World Championship. That will make Scott and James and all of our other safety inspectors' jobs that much easier. You will get through safety inspections and get on to, get your marketing display set up and get in some practice time. So again, just encouraging you all to reach out. Yeah, any other questions? Thanks everybody for hanging in there. I know it's hard, it's late in the afternoon, so thanks. And with that, I'm going to stop recording. So we'll thanks again, Matt, for a great job, and Scott and James for chiming in, and I'll end recording now.